You already have an answer for this one. That's the problem. Ask someone what happens to their body after they die, and you get the same shrug. You rot, you burn, you're gone. And the word doing all the work in that sentence is gone, which you have never once stopped to define. So define it. Where exactly does gone go? You can't answer that because there is no answer. Nothing in the universe has ever gone anywhere. Not one atom of you will be destroyed by your death, not by rot, not by fire, not by 10,000 years in the ground. That is not a comforting metaphor. It is an accounting rule. Start with the inventory, because you have never taken it. You are, by best estimate, about 7 octillion atoms. 7 followed by 27 zeros. That is an estimate rather than a measurement, and it swings with your size and your hydration. But the order of magnitude is solid. By mass, roughly 96% of you is 4 elements. Oxygen at 65%, carbon at 18.5%, hydrogen at 9.5%, nitrogen at 3.3%. But mass is a liar. Count the atoms instead of weighing them, and the ranking flips. Hydrogen is the lightest thing there is, so it barely registers on a scale. And yet 62 out of every 100 atoms in your body is hydrogen. So the thing you call your body is mostly the lightest element in existence, and you would never know it from standing on a scale. None of those atoms are yours, by the way. You are renting. Now here is the part your shrug skipped. Rotting and burning are chemistry. That is all they are. Chemistry is the business of electrons, the outermost, loosest, most negotiable part of an atom. A chemical bond costs a few electron volts to break, and that is the energy scale of everything happening in a decomposing body. The nucleus is a different country. Nuclear binding energies run into millions of electron volts per particle, roughly 1,000,000 times higher than anything chemistry can bring to the table. Cremation runs between 760 and 1150 degrees Celsius. That sounds like a lot. Because you are a mammal. To a nucleus, it is nothing. It is not even in the neighborhood of the neighborhood. You can burn a body for 3 hours, and every nucleus in it comes out the other side unchanged, unbothered, completely intact. Fire does not destroy atoms. Fire rearranges which atoms are holding hands. That is the entire event. Now I am going to hand you an exception, because there genuinely is one. And then I'm going to take it back off you. You are radioactive. Everyone is. You carry about 140 grams of potassium, and a sliver of that, 1/100th of 1%, is potassium-40, which is unstable. That is roughly 4,400 decays every second inside your body. Add carbon-14, and you are running near 8,000 nuclear events every second for your entire life. So there it is. Proof that atoms can change. Except, look at what changing actually means. Potassium-40 does not vanish. It becomes calcium-40, or argon. Carbon-14 becomes nitrogen-14. The particles inside the nucleus are conserved down to the last one. The atom changes address. It does not check out. And if you're waiting for the protons to give up and dissolve, physicists have looked. Super Kamiokande, 50,000 tons of ultra-pure water under a mountain in Japan, has spent years watching for one proton to die. It has never seen one. The floor on a proton's lifetime is past 2 × 10⁻³ years. The universe is not quite 14 billion years old. The protons in your body are stable to a number. 24 orders of magnitude past that. On any time scale that has ever mattered to anyone, they are permanent. So if nothing is destroyed, the question was never whether your atoms survive you. The only real question is, who gets them next? Decomposition starts within minutes. Your own cells go first in a process called autolysis, meaning self-digestion. Enzymes your cells kept locked away get released and eat the cell from the inside out. Then the gut bacteria stop asking permission. Proteins come apart into amino acids, and those into ammonia, hydrogen sulfide, and the two compounds actually named cadaverine and putrescine, responsible for the smell you are imagining. Carbon leaves as carbon dioxide and methane. Under the body, the soil changes. Forensic researchers call it the cadaver decomposition island. At a facility in San Marcos, Texas, they watched the nitrogen in grave soil more than double in 2 weeks. That nitrogen was you. It is fertilizer now, and the plants above you will take it without a word of thanks. Cremation is faster and no cleaner an escape. 90 minutes to 3.5 hours in the furnace, and the soft tissue oxidizes into carbon dioxide and water vapor that leaves through the flue. What is left in the tray is not ash. Ash means burnt organic matter, and there is none left. What remains is your skeleton's mineral, calcium phosphate, ground to powder. 4 to 9 pounds of it. The urn on the mantelpiece holds pulverized bone, the least interesting fraction of you. The interesting part left through the chimney, and it left fast. And this is the part that should unsettle you. A molecule of carbon dioxide spends 4 to 5 years in the atmosphere before something takes it. Plants pull down over 100 billion tons of carbon a year, and isotope studies put the recycling time at roughly 1.5 years. Which means the carbon that used to be your hand is not going to spend eternity drifting. It is going to be a leaf. Probably within a decade, possibly within a year. The water is faster still. You are about 60% water by mass, and a water molecule that reaches the atmosphere stays up there about 9 days before it falls as rain. 9 days. That is how long your body's most abundant material takes to become weather. If you're finding this useful, subscribe. I take one physics idea a week and break it until it makes sense. There is an old thought experiment here. James Jeans, writing in 1940, worked out that a single breath holds around 25 sextillion molecules, and that if you let one breath scatter through the atmosphere for 2,000 years, you inhale about 1 molecule of it right now. It is Julius Caesar in the popular telling. Be careful with it, because the calculation assumes perfect mixing and molecules that survive intact. It is an order of magnitude argument, not a proof. But the direction it points is correct, and it is not romantic. It is arithmetic. Now turn around and look the other way down the timeline. Everything so far has been about where your atoms are going. You never once asked the harder question. Where did they come from? They were not made here. Take the hydrogen. 62 out of every 100 atoms in you. That was made in the first 3 minutes after the Big Bang, when the universe was hot enough to be a fusion reactor and cooled through too fast to build anything heavier than lithium. 13.8 billion years old as time is. By atom count, you are mostly a survivor of the first 3 minutes of existence. The carbon took longer, and this is the beautiful part. Carbon gets built inside stars by slamming 3 helium nuclei together at 100 million degrees. The trouble is, the middle step makes beryllium-8, which falls apart in under 1/10 of a femtosecond. Fred Hoyle worked out that carbon could only exist if beryllium and helium lined up with a specific excited state of carbon at 7.65 million electron volts that nobody had ever seen. He predicted it purely because we exist. Caltech looked. It was there. Your nitrogen. The nitrogen in every strand of your DNA came from the CNO cycle inside stars heavier than the sun. The calcium in your teeth and the phosphorus in your bones came out of dying massive stars thrown across the galaxy by supernovae. And in 2017, we watched a piece of this happen live. 2 neutron stars collided 80 million light years away, and we caught the gravitational waves and the light together. The collision forged roughly 5/100ths of a solar mass of heavy elements: gold, platinum. None of this was made on Earth. All of it was here before the Earth was. Every atom in you is older than the ground you will be buried in. So go back to that shrug you started with. You said you would be gone. What you meant, and did not know you meant, is that a particular arrangement would stop. That is true, and it is the only true part. The pattern ends. The material does not so much as flinch. Richard Feynman put this better than anyone in 1955 in a talk called The Value of Science. He was not talking about death. He was talking about being alive. He pointed out that the atoms in your brain now are not the atoms that were there a year ago. His words: "The thing which I call my individuality is only a pattern or dance. The atoms come into my brain, dance a dance, then go out. Always new atoms, but always doing the same dance, remembering what the dance was yesterday." You have been swapping out your material your entire life and never noticed. Death is not a new process. It is the same process, running without the part of you that kept insisting on the choreography. And I do not want you to find that consoling. Consoling is small. I want you to find it accurate. 13.8 billion years ago, some hydrogen. Then stars that lived and died to build carbon and oxygen out of helium and pressure. Then a supernova. Then a planet. Then, briefly, an improbable arrangement that could look up and work all of this out. That is not mysterious. That is magnificent. And the atoms doing it are not finished.